Hello again, everyone. My name is Cureton, Senior Journalist from XR Today. As always, bringing you the latest and greatest from the VR, AR, and XR industries. Today, we're going to be speaking with an amazing executive that's going to be talking about things happening, taking shape in Nokia. So today we have on Thomas Hainzel. He is the head of Digital Industries Evolution and Partnerships for Nokia. Thomas, it's a pleasure to have you on the show today, and great to have you here.
Pleasure to be here. Thanks for the invite.
Okay, lovely. We're going to have some really interesting things to talk about, which is telecoms and the metaverse. So we're specifically speaking about the industrial metaverse. Now, we can talk a little bit about Nokia's position on the industrial metaverse. How would you define it?
Yeah, so if you look into the industrial metaverse, the industrial metaverse combines the physical, the digital fusion, and the human augmentation for industrial applications, right? So it contains, I would say, digital representations of the physical environments, right? Of systems, of assets, of spaces, right? That people can work in, that people can control, communicate, and interact with. But all these, let's say, assets, system, environments, the whole industrial metaverse and the use cases we see there, they all demand quite high performance, secure, reliable, and real-time low latency networks and connectivity. No matter if that is a fiber connectivity in a factory or some optical connectivity, if that is IP routing and switching in a data center that needs to cope with the amount of data we see in the metaverse, or if that is a public or a private 4G or 5G campus network. And we as a Nokia, we provide exactly that technology. So we understand ourselves as a B2B technology innovation leader, and we exactly unlock those industrial metaverse use cases. So we can help our partners and our customers to plan, to deploy, to operate those high demanding and scalable and flexible networks that they need for the industrial metaverse. And we also have that as part of our recently launched strategy. And what comes on top in the Nokia environment is that we have a quite strong understanding of the different industries. Because looking at the industrial metaverse, there is a difference if we, for example, talk about a metaverse in the energy domain or in the transportation industry, in manufacturing or in public safety. And we have industry experts at hand that understand the use cases and the languages, the technologies and the use cases behind it, and that can help mapping that to the industrial metaverse. And that's what we do, right? And that's what we also maintain as an ecosystem of partners along the full value chain play as Nokia, because we don't see ourselves as the only player in the metaverse. Nobody can own the metaverse. Nobody can operate it on him or herself. But it's really a combination of partners, a combination of different research, build, and go-to-market partners that are needed to deal with the complexity of the topic.
Absolutely, and you mentioned something very interesting about the metaverse, is that no one company can actually own or create it. It's a group, it's a collaborative effort across the entire tech community. And so that's one reason why I'm so excited to speak about this with companies like you, with companies like NVIDIA and others who are contributing to the overall work that's being done there. So lovely. I wanted to ask you a little bit about some of those challenges that are currently posed to the networks. What are the challenges posed to the networks from the metaverse and actually scaling it up so that it can become a reality?
Yes, from a network perspective, the maybe most obvious challenge is the capacity and the throughput that those industrial metaverses require, right? Because in some of the industries that I was just mentioning, we see, of course, legacy technologies, and they are simply not made, they are simply not ready for these high capacity, high bandwidth data streams that will come in, let's say, in parallel, in real time for those critical use cases. So capacity throughput in the network is definitely one of the obvious challenges that we see. But it's also around integration and bringing the different architectures and topologies together. Because if we talk about the industrial metaverse in particular, we talk about industries that have heavy machines, that have asset-intensive operations. And that means that you need to bring the IT world, so the information technology world, and the OT world, so the operational technology on the shop floor in the warehouse. You need to bring those two domains together, and integrating those to make the metaverse work, to bring all the data points together, is not always easy and requires integration. And that is what we also see when we discuss these days the metaverse topic with our customers. And then we also have a couple of new features that, of course, challenge the current network deployments. So if we, for example, look into the 5G networking, in the future, we will see native positioning. We will see positioning technologies being part of the 5G network, right? So there are new technology stacks, new features that are coming. We talk about quantum safe encryptions on the optical side, for example, when we talk about the optical networks, right? Or we talk more and more about hybrid cloud models with our customers. But all those new technologies, those new features, of course, they place, I would say, challenges to the existing networks. And then obviously a topic is around security, right? So cybersecurity and dedicated security is key, because if we think about the metaverse, we are bringing many different data points, we are bringing different domains together. We create new super meaningful insights. So data sensitivity is quite high, and we definitely need to take care about the security end to end in the network, but also on the device and the application layer.
Absolutely, and there are so many components that are being, integrated into these metaverse technologies, which is why, it's so crucial that when people ask, well, where is the metaverse? It's like, it's not just Meta developing it. It's not just this company or that company. It's a group effort that is going to take a lot of, brilliant minds coming together to actually resolve those challenges. So that way it can become a reality. Now, speaking about that, I wanted to ask you a little bit. You posted a report from EY, which indicated that nearly 60% of businesses with future metaverse plans had already begun implementing those technologies. Now, for a company like Nokia, how would they begin rolling out the industrial metaverse? And what kind of time frame are we looking at?
Yeah, so what we usually do, or if you ask about something like an overall guidance, right, I would say let's start small, right, but then grow big over time. And what do I mean with that? So what we usually do with our customers is we implement something like an early proof of concept or a first trial project, not only to test these new technologies or to bring the metaverse to life, but also to make the organization, to make the people, to make the processes familiar with that industrial metaverse and with the new use cases. It's not only a technology topic about deploying a new network, it's also about the organization, people, and processes behind that. And what we have seen in various projects is that I would say 12 to 18 months is a good time frame that it needs until the existing corporate structures that are sometimes a bit more reluctant to change, some more, some less. But in the end, there is some time needed, like 12 to 18 months, that these metaverse initiatives, that they go into the organization, that the organization can digest it, and that also all the stakeholders involved kind of understand that before we go into a broader rollout. And that is what I meant by saying growing big. Because when you are ready for the rollout, right, then you go to multiple facilities, you go to additional technologies, you go to new use cases that you roll out. But then you need to have a thought about, let's say, scalability. So do I have enough capacity in the technology? Do I kind of, go for the next level in the technology? Do I have my people, my ecosystem, my partners ready? Do I have everything that I need to get the job done and not stop in the middle of the journey? And that's why we always say it's a technology transformation, but it's also a people and organizational transformation. And that's why, for example, also communication between the different stakeholders is key. So we talk a lot to factory heads, to plant operators, to supply chain managers, to get their buy-in, to get their commitment, but also to tell them and to show them how those new digital experience looks like, right? And we were talking about proof of concepts, and as a starting point, I mean, let's face it, when we talk about digital or virtual twins, for example, or when we talk about predictive maintenance machine use cases on the shop floor or some automated robotics, those are already first steps towards the metaverse. Those are the first step to grab data, to provide some simulation data, to provide more than just the manual stuff that we are used to from the past, right? And we will see more and more technologies, 5G, 6G, and optics coming into play to make those use cases a reality. So again, that's why we say, let's start small. Let's start with a first project, a first trial, and then grow big over time. And let's pull all components of the organization into that transformation journey.
Definitely, definitely. And there's going to be a lot of new use cases that people will want to test with the new ecosystems, the new 5G networks. And so that way the industrial metaverse can start to show people the kind of return on investment that they can, prove to a lot of the businesses actually using them. So that's one thing we've been speaking with a lot of companies. It's like, okay, we invest in this. We want to make this work. How do we not go over budget? How do we make sure that this is given the best experience for our clients? So these are amazing things that we can chat about, especially as an industry itself, as to how it's going to work in the end. So just moving over to the next one, I wanted to ask you a little bit about some of those success stories that Nokia has had with its 5G and its 5G infrastructure. And are there any particular clients that you're able to speak about, or situations, scenarios in which you have created an industrial metaverse solution that has actually worked and shown that kind of return on investment?
Yeah, of course. I would say it's a mix here between customers and partners that we are working with when it comes to 5G and the industrial metaverse use cases. I mean, one of the cases that I would like to mention here is maybe Lufthansa Technik. So Lufthansa Technik is a Germany-based aviation maintenance and overhaul provider, right? So they are maintaining and repairing airplanes, let's say from airlines across the globe. And what they have implemented as, I would say, first industrial metaverse use case is a use case they call virtual table inspection. So imagine that you have the maintenance and the overhaul procedures of an airplane, and usually they just dismantle the whole engine, the whole plane, for example, in a hangar in Hamburg, right, in Germany. And then the engineers of the different airlines, they need to travel to Hamburg and to do all the inspection and all the maintenance stuff, right? So it's a quite cost-intensive and travel-intensive process. And what Lufthansa did is they implemented a virtual table inspection, which means that an engineer from Lufthansa Technik on-site uses HD video streaming, let's say voice and video communication, to that airline technician that is sitting not in Hamburg, but is sitting remotely somewhere across the globe, and that they are kind of doing a virtual and remote inspection of the airplane, which of course reduces travel time and reduces effort for the airline to travel to Hamburg and to do the inspection there. And that is one of the first, I would say, metaverse use cases, because we need real-time, high-capacity networking. We have voice and video communication in real time between those two units, right? And the next obvious step is to create a digital twin and to interact, and also with the technical part and all the maintenance data that you need for that technical part. So we started that use case right before the pandemic hit the world, I would say, and we are now already in production and thinking about the next use cases. So this is a nice story also to tell, this start small, grow big story, right? Because we started with a proof of concept and with one first use case, and we're now scaling into the next ones, into the industrial metaverse. So that's definitely one example. Another one I can think about is one of our partners, and that is Dassault Systems. So Dassault Systems is a French-based company that is providing, let's say, virtual or digital virtual twin immersive experiences. So they are a software company, and what they do is they build digital models, digital replicas, so digital or virtual twins of factory shop floors of assets, yeah, and they provide a solution where you can use, for example, smart glasses, a kind of controller, and a backpack with all the technology and the battery and everything to literally virtually walk the shop floor and review configurations, do simulations with the different machines, discuss productivity outcomes, and increase the efficiency of a remotely located factory. And that again, of course, reduces travel times or improves the kind of experience how managers, but also kind of plant operators can optimize their factory processes and experience. And that's also, I would say, already a first step into the industrial metaverse. If you think about then adding additional data from outside, from the supply chain, from other ecosystem partners into that virtual or digital twin, and then of course you have a full-blown end-to-end experience in an industrial metaverse. So that's then, I would say, maybe the final outcome that we will see in a couple of months and years.
Excellent commentary on that. And one of the interesting things that is the complexity of the types of solutions needed to make this possible, because there's remote guidance, there's all sorts of monitoring of specific parts. There's also seamless communications between people if they're using, for example, AR smart glasses to do the digital walkthrough or the virtual walkthrough. So there's so many different things that need to go properly in real time for this all to be, a success. And so one of the things about 5G is that helps to make it possible. Whereas in the previous iterations like 4G, 3G, it was much more difficult to do so. So yeah, I was going to ask some of the things that we could talk about at the network and telecom level. So some of the questions I had to ask Nokia, because I'm very interested in what you would have to say about this. How does the industrial metaverse look at the telecom level? Do you think it will have numerous test beds? Are they going to be more private networks? Are they going to, use more of the core networks that other people share? And what kind of use cases would be suitable for either of those?
Yeah, so on the network level, and I think the answer here, or at least our view here, is again a mixed one, because we don't see, let's say, one single metaverse, right, that will cover everything. So we talk more about a combination of multiple scenarios, right, or multiple industrial metaverses depending on the use case or the industry. Because, for example, let's take a metaverse in the medical environment where maybe training or some educational use cases are implemented. That's different than what we see in the manufacturing space. Let's take the Dassault Systems case we just discussed, or what a rail operator will use when they have a digital or a virtual twin to kind of implement their industrial metaverse. So it will be industry specific. But what we see is that it will be on a network and telco level, it will be a combination of multiple technology elements. And one of them is this multi-access connectivity that I was just talking about. So we will see fiber as well as, IP optics. We will see 5G, 4G technology. So we will see many technologies coming together to provide the connectivity depending on the use case scenarios. We will see a lot coming in high-speed computing functions, be that data centers or again the interconnect between data centers, that in the end will provide the secure and ultra-fast and low latency networks. So that is what we will see if we talk about connectivity and computing. But we will also see trends like, and we also already have them today, let's face it. So we have, for example, edge computing, which is definitely a must-have if we talk about enterprise applications. We want to bring closer to the data sources, and we want to have faster and maybe greater processing of the data and more security. So this is also something. It's not only the connectivity itself, it's also the data processing, the computing functions, and the security that we will see as key elements in the network architectures of the future. You were asking about campuses, test beds, public, private. Metaverses, they will leverage, depending on the use case, public as well as private networks. If it's more on manufacturing, on automotive, on a kind of campus, then the campus network capabilities, they are made for the industrial metaverse. They provide exactly these high reliable, these robust, these high performance networks. So we will see those campus networks being a very important part of the industrial metaverse. But we will also see the public networks being part of that, because if we talk about logistics, supply chain, or kind of data that is coming from the outside of the campus, then we are back to the public networks. and we will see those being part of it. And let's also be honest, we will also see legacy networks being part of the industrial metaverse, because if you have old and heavy machines that are connected via copper cables in your factory, you might not change that cable, but you might connect it to the overall metaverse so that the data of that legacy machine, 50 years old, is also considered when we do the metaverse calculation. So that's why we see this as an integrated approach. And I would say test beds and campus networks will be a starting point, as mentioned before, also in terms of the growth strategy of organizations. But we will see more and more coming across the different network technologies and domains.
Definitely. And, it's very interesting that, the interconnectedness between a lot of the legacy, the old and the new, the the cutting edge and the tried and tested. These are going to be really interesting trends that we see in the near future as they do decide to build the industrial metaverse. So, for example, like integrating 4G and 5G, using very sensitive kind of technologies to use very low bandwidth or low bit rate kind of communications across vast differences. That's going to be extremely important, especially that with 5G, it's sometimes more difficult to get the signal to transmit longer distances because the base stations need to be closer together so they're better suited for urban environments in some situations, depending on how the network is developed. So, there's a lot that people have to look at and kind of map out over the next few years to kind of see how it's going to go. But yeah, we could talk a little bit about the digital twins, because you mentioned something with Dassault Systems, is that they have to use digital twins to create this kind of, industrial metaverse kind of commodity. They're going to be using a lot of digital twins for their own operations, for the operations of clients, and things like that to monitor the industrial metaverse in real time. Now, why are digital twins so important to the industrial metaverse? How do they support these things?
Well, I would say digital twins, they are one of the first or a very early use case, and also, as you rightly said, one of the most promising applications that we see in the industrial metaverse. So what are these digital twins? They are virtual replicas of kind of real asset or real scenario. And why are we discussing them as one of the first use cases? Because they are really helping a couple of organizations or companies or industries to, in the end, plan faster, to be more accurate, to improve their process efficiency, or to optimize operations and much more. So they are a very good starting point. Yeah? And I think, interestingly, if we again step back to the example of Dassault Systems, let's say, they differentiate between a digital twin and a virtual twin. So the digital twin is a bit the starting point where we see a lot of data coming together from the past. Let's say what we have collected from the shop floor, for example, or from some plant, right? And when we then move on to the virtual twin, it's really about bringing together the physical and the virtual world to add procedural properties, to add conditions and simulation capabilities, and even artificial intelligence and external data sources. So it's getting much broader, and there are much more capabilities and much more opportunities with those, let's say, virtual twins than with the starting point, which is the digital twin. And what we see then, these virtual or digital twins they really help facility or plant operators to, for example, analyze their production, right? To analyze the whole plant and the facility data in real time in a virtual environment. It's not about looking into Excel sheets and looking into charts. It's about seeing what happens in the factory. And that gives you a complete different point of view and complete different opportunities to then make better decisions and to also collaborate in that environment, let's say with colleagues, for example, and discuss how to optimize the production lanes, what to do next, right? So it puts all those discussion processes on a different level. You can do simulations, and you can really use real-time data, predicted data, and AI-generated data, and all that goes together and gives you a view on how the production might look like tomorrow or in 2 weeks or in a year if you now kind of change the parameters, right? And if we go a bit down to the more physical, let's say, advantages that we see with digital twins and why we are discussing them so much is they also reduce, for example, waste, time, and effort when it comes to prototyping. You don't need to invest in the automotive industry into the next 20 models, into a lot of metal and into a lot of production of real cars. You can do that virtually, and you can start prototyping on a virtual basis. Yeah. And you can then come together also when you think about international teams and discuss those results. And that, of course, also helps to overcome distances, for example. So there are many, many advantages of digital twins. And what we also see is that you can start with a, let's say, smaller kind of setup of a digital twin and then grow over time as soon as technologies and organizations mature in the topic. And that's why we see a lot of companies starting these days with digital twins.
Absolutely. You raised some very interesting points about that. Firstly, we speak about digital twins being used to kind of create simulations. So I remember a while back at one of the industrial Internet of Things conferences back in, I think it was in Texas, that they were able to use with, I think, GE Digital, they were able to monitor a bridge's, design, how it degraded over time, certain things that happened to the structure over time, and then they could design even better, models later on using that data. And doing this at the AI level, you can create 30 different kinds of prototypes in the time it takes to do one, which is amazing. And additionally, you don't have to keep sending back clay models to your colleagues all the time. You can do it in real time with something like NVIDIA Omniverse, which is another incredible invention done by the guys at NVIDIA in Santa Clara. So, there's so many possibilities. That's one reason why I get excited about the industrial metaverse in general, because the capabilities that it will have are unprecedented. And I think that this is something people will have to pay attention to when they say the metaverse is dead. No, not at all. It's actually going to be for the industry. And I think that's going to be where the first places we see it, emerge over time. So, last question I want to ask you before we close things up. We talk about the Open RAN Alliance. When we speak of the metaverse, how will the Open RAN Alliance, which I think you're a member of, how will that support the development of the metaverse?
Yeah, and let me maybe come back to your point. So the metaverse is dead. I fully agree. No, it's not. We are just at the beginning of it, right? And we will see a lot coming down the road in the next couple of years. So back to your questions on the Open RAN Alliance. So we as a Nokia, we are leading partner of the Open RAN Alliance. We have a lot of activities running up there. So we of course look into the 5G RAN performance. We look into security, reliability, efficiency, and all that requires, I would say, innovation when it comes to hardware, software, and services across the radio access network domain, right? And we have also openness as part of our identity at Nokia, and we collaborate with many different ecosystem partners to exactly enable those connectivity and networking solutions for the future and to enable such use cases. How does that relate to the industrial metaverse? Well, I would say the industrial metaverse only can come to life if a couple of partners and if whole ecosystems work together. And that also means that we need to be open, that we need to see that there will be multiple vendors on the software, on the hardware, on the device layer, on the connectivity, and on the platform layer. All those players will come together. And that's why Open RAN is important here to make sure that this seamlessness, that this integration of the different domains, be it IT and OT, be it different network topologies and technologies, that all those go together, that security standards are aligned, because security is key in the industrial metaverse, right? And that we also talk about interoperability and lifecycle management of network functions. We are used to that from the past because, looking into all the standards for mobile network technologies like 3GPP, that is what is our bread and butter. So interworking and kind of interoperability is key. And we now want to use that experience, also I would say, our knowledge in defining those interfaces, being front-haul interfaces, being near real-time interfaces, intelligent controllers or whatever, to make sure that our experience from those very open, standardized discussions from the mobile network technology, that they kind of get injected into the industrial metaverse, because bringing together hundreds of parties and hundreds of use cases into this industrial metaverse bubble needs integration, needs alignment and interworking. And that is why I think we can benefit from how we behave and what we do today on the Open RAN side, that this can be beneficial for the industrial metaverse environment.
Absolutely. Yeah, just as a quick note, making those open standards, the interoperability is another passion of mine. And one thing I do see is that businesses and organizations, institutions are arguing and advocating for those open standards. For example, NVIDIA created they started working more with the Open USD, or I think it was kind of like the standard file system that they needed for a lot of the digital assets. So these are things that we'll see in the near future. And so, I really, really appreciate the time that you spent today, clarifying these things and speaking to our audiences about that. So thanks so much for that.
Thank you for the invite.
Okay, lovely. Once again, everyone, we've been speaking to Thomas Hainzel. He is the head of Digital Industries Evolution and Partnerships for Nokia. Once again, my name is Cureton, Senior Journalist for XR Today. And if you'd like to follow more conversations like this in the future, please do so at the XR News hashtag on Twitter and LinkedIn. Thanks again for joining us, and keep following the news. And until next time, bye y'all.